All right, guys, I'm super excited about this webinar today. First and foremost, I just want to thank everybody for joining us on the webinar and investing an hour of your extremely valuable time. My name is Stephen Lager-Marcino. I'm the president here at TRC Electronics. I have more than 20 years of electronics industry experience, all specializing in power supplies and with a background in electrical engineering. I see a lot of new engineering names here in the webinar today. So for those of you who are new to TRC Electronics, TRC Electronics is a specialized distributor with an exclusive focus in power supplies, and it is our mission to provide you the power to succeed. Now, the intention of this webinar is first and foremost to provide value today. Your time is very valuable, and we want to make sure that we're providing you value. And why are we doing this webinar and this topic today and inviting you all here today? Well, over the years, we've worked with tens of thousands of design engineers on projects that use power supplies. And what typically happens, about 50% of system designers are actually not on the right power supply product when they initially select a power supply. So we decided to analyze all the data, years of data, and we came up with the top 5 most common mistakes made by system designers when selecting a power supply. You know, a fundamental philosophy that we have here at TRC Electronics is working smarter. We really truly believe in working smarter, and one of the ways you can accomplish that is from learning from other people's mistakes. So we decided that we're going to share the data and the mistakes that other engineers make and system designers make so that you can avoid those mistakes, you can work smarter, and you can be more successful. And you know, right now, not selecting the right power supply can cost you thousands of dollars. It can delay you weeks, if not months. And in today's environment, with all the supply chain disruptions, with the inflationary pressures of commodities such as power supplies, a mistake in this early design phase, selecting a power supply, is amplified today. So we just think it's even more critical to get ahead of this today than it is ever. Melissa alluded to it later in this webinar. I have an awesome offer for you guys. We have an amazing Meanwhile promotional offer for everybody here that is going to be available exclusively at TRC Electronics. You will not find this anywhere else in the distribution industry. You don't want to miss this exclusive promo, so stay tuned. This is by far the best Meanwhile promotion that has ever been offered. Now, this webinar is intended to be interactive, so please type your questions in the chat. Raise your virtual hand and we'll answer as many questions as possible. Turn your cameras on. We'd really love to see your faces. There's a lot of new people to the organization here. We'd like to get to know you a little bit better. So before we begin, I have 2 co-panelists. I'm going to introduce them to you and then we'll get into the topic right away. First, I want to introduce you to Mike Patagna of TRC Electronics.
Thank you, Steve. Hi, I'm Mike Patagna, Vice President of Engineering here at TRC Electronics, and I've been serving the power supply industry for over 20 years. And here at TRC, I'm leading an amazing team of engineers that are helping our clients select the right power supply for their application.
All right, very good. And I know we have a very special guest for Meanwhile. We have Brian Liu from Meanwhile. Hey, Brian, how you doing today, buddy?
I'm good. How are you? Thank you, Steve. So my name is Brian Liu. I am the application engineering manager at Meanwhile USA, and I have been with Meanwhile for more than 10 years. And just like myself, just select the right power supply for the right application, and also helping customer to resolve application issues.
All right, Brian, you ready to get going, buddy?
Sure, let's go.
All right, let's go. So let's get into the top 5 mistakes that system designers can make when selecting power supplies. We're going to inform you and we're going to help you guys get a little bit more successful selecting those power supplies. Okay, here we go, guys. All right, first common mistake that system designers make. A power supply is selected and it has the incorrect safety certifications and compliance. Now, when one of those scenarios is when somebody selects a power supply that is certified for industrial applications, and they're attempting to use it in a medical device application. Mike, why is this a problem for a client when they select an industrial power supply, but they're really trying to use it for a medical device application?
So you see here, Steve, what typically happens is those two agency certifications, you have the UL 62368-1 and the 60601-1, they're very similar, but they're actually two differentiators that medical power supplies need to have inside the power supply. One of them is that you have to have dual fusing, because if you have a fault condition, you want to make sure that either if the fault happens on the line or in the neutral, you have dual fusing for that. The other is that the power supply construction is actually constructed in a way where the spacings on the PC board, which we call the creepage, which is the surface area between the input and the output, as well as when they don't have enough surface area, they use a clearance, which is where you see that gouge on a PC board for that type of isolation. And of course, the magnetics are also different in a medical power supply to give you that separation from input to output.
Very good. You want to comment on that a little bit, Brian?
Yeah, beside the creepage and clearance, medical power supply also require to have higher isolation as compared to the industrial power is 1,000 higher. So 4,000 for medical and 3,000 for industrial. I mean, the main goal here is to the medical standard want to make it more stringent, more safe for patient. Okay, because we're doing medical device, and also liquid current as well. Liquid current is 5 times more stringent as compared to industrial power supply, because patient, their health is are not good as compared to normal person. So require lower liquid current is make more sense. I mean, so in summary, if you are going to design a medical application or medical products, you have to use a medical power supply. Otherwise, when you go to safety, they're going to flag it. They're not going to let you go. Okay.
Very good. Awesome, Brian. So let's get back here to the next mistake here in this aspect. Well, now the flip side of this, selecting a medically certified power supply for an industrial system. Brian, maybe you could speak a little bit about this. Now, the other way around, you have an industrial system and you're selecting a medically grade power supply.
Yeah, I mean, in general, it should be acceptable in terms of safety point of view, because medical power supply, like I said earlier, is more stringent in terms of liquid current, high part, and isolation. However, it really depends on the application. So if the application for industrial require limited power source, for example, okay, the power supply has to be limited power source, so that the application can use lower fire rating components, then medical power supply won't work, because the standard medical power supply doesn't do any LPS rating. Okay, so you have to basically use an LPS power supply, which is under 62368 industrial application only. Okay, another good example is 508. If you do industrial control application, if you do 508A, okay, then your power supply had to do 508 or 62368. The UL inspector who come to your factory every 3 months, they're going to flag it and say, okay, medical power supply is not falling to my UL 508 standard. So you have to use 508 or you have to use 62368. So those are the two. So in summary, basically it's application dependent. You have to really look into what you're doing in order to use medical power supply.
And also, it's a commercially poor decision as well, Brian, because, well, wouldn't it be true that medically grade power supplies are going to typically be at a higher price point than industrial rated power supplies? So if you're picking a medically grade power supply, you're basically you're overpaying for the power supply what you really need for the application.
Yeah, correct. I mean, nowadays everything is cost sensitive. I mean, if you don't need to use medical power supply for industrial application, don't use it. I mean, we have, you select an industrial power supply that's suitable for the application is good enough.
That's great. And the other aspect here is we're also seeing a lot of home use applications now. And so there's different safety and compliance issues that are occurring now with the increasing number of home use applications, especially once COVID hit. Everybody's doing more at home. Mike, you can talk a little bit about that.
Sure. So with home use, here you have a scenario where you have different types of functions within a home use equipment. It could be an exercise equipment, for example. And the safety aspects of this are specifically now targeted towards the leakage current. You see that the IEC 62368-1 does have leakage current specs and limitations, but for home use, we typically want to see those lower, especially if, let's say, a customer may disconnect the ground and not have a ground when they're supposed to have the ground, with those cheater plugs, that could create a problem.
Yep.
Yeah. So, and also I want to point out, as an example, like now popular home use application is coffee maker or a live fitness. Though usually the live fitness exercise equipment usually use two power supply. So the leakage current that required for the equipment is the total leakage current of the two power supply together. So it easily go over 750 microamp, which is required for the home use products. So in that case, then I would recommend to you medical power supply because they're like 300 micro each. And then if you have two, then they're going to be under 750 micro. So you're good to go with safety.
Right. And actually, so Brian brings up a good point. Now here you have a scenario where you have to have a medically approved supply because you get the lower leakage current. And then you have other requirements for the ITE spec. So typically what happens here, especially in medical equipment, we can actually combine the different voltages into one product. And modular power supplies has been something that we've been able to do in the past with a lot of success. So with a modular power supply, you can have your 12, you can have your 24 and 5. They can be split up on the DC end, but then you have only one connection to the AC plug. And what that does is with that one connection, you can have a lower overall leakage current and still supply all the power to the various devices.
All right, awesome, guys. Let's get to the next common mistake, and that's when we select a power supply and it doesn't meet the operating temperature specifications properly. So one of the things that we put a graph here of a typical derating curve of a power supply. Now every power supply has a derating curve, and on a data sheet of a power supply, you can see the derating curve. And here it's really important to understand that you may have an ambient operating temperature range of a power supply. And in this particular example here, we have a minus 30 degrees Celsius to plus 70 degrees Celsius operating temperature range. And let's just say that this is a 300 watt power supply. Well, up to 50 degrees Celsius, you can get a maximum of 300 watts. But once you go above 50 degrees Celsius in your ambient temperature, your power supply power rating starts to derate, and it's no longer a 300 watt power supply. And this is a mistake that system designers can make and not pay attention to the actual derating curve, and also being aware of what their actual operating temperature environment's going to be. So, maybe Mike, you could talk a little bit about this as well.
Yeah, so here, this is typical where you may have a system that's rated for 50 degrees C, but then what about the ambient conditions inside the system? See, that system has heat generating components, including the power supply, and a power supply's ambient may be different than the system ambient for the overall system. So it's going to typically be a little hotter. And that's why it's so important to run the temperature specs and actually predict what the temperature is going to be. And that's why when we when we get into this situation where we're a client and we're asking them these questions, we are actually asking them, what is the overall ambient of the power supply, not just of the system.
Right. And another aspect of this is also being a power supply has inappropriate cooling for the type of application. So, different types of applications are going to require different types of cooling, and power supplies can vary in what type of cooling method is used for each power supply. So let's talk a little bit about that, because we've got power supplies that have all different types of cooling methods. It could be an internal fan in a power supply. It could require external fans. It could be conduction cooled, convection cooled. So let's talk a little bit about that.
Well, first I'll mention the fan-cooled supplies. Because what typically we see here, we have a repair center at TRC, so we see a lot of supplies coming back that have failed. And one of the problems with fan-cooled power supplies is that clients may not understand that they may be corrosive environments, so they may be humid environments in that application, and the fan will inhale that corrosive contaminant, and over time, we'll see corrosion built up in the power supply and also dust. So using a fan-cooled supply in the wrong application could be a problem. And in those situations, if you have to use a fan, then we'll recommend that they have conformal coated power supply, so at least that coating will protect the electronics from shorting out over time. And then the other one is we have a client that actually has built a large vehicle, and they put their fan-cooled power supplies inside of a sealed box without any air exchange. So over time, the supply would just simply heat itself. So what we've done with that client is we were able to help that client design some baffles so that they can take in fresh air and exhaust out the heated air, and it made that application more successful.
So I see Gabrielle comments that their devices are designed to be used outdoors around the world. So they're in a variety of different types of operating temperature ranges. I wonder if we can bring Gabrielle on, and just if Gabrielle can share. Gabrielle, we're going to ask to unmute you. Maybe you could talk a little bit about the different types of temperature ranges and how you're addressing that right now. We'd love to hear about it. You find her and we ask to unmute her, or him?
Yes, what you would like to know.
There you go, Gabrielle. So maybe you can share a little bit. So you commented that your devices are used outdoors around the world. So what is it? You have probably quite a different range in temperature from very cold to hot weather. Would that be the case in your particular instance?
Yeah, we have equipment installed in Canada, and as well as Dubai and United Arab Emirates. Right.
And so what kind of power supply do you use in that environment in order to meet those wide temperature specs?
Well, right now we are using one of the Meanwell power supplies.
Do you remember which one it is?
Actually, not at the moment.
Okay. And it's meeting, so this is great. So you use a Meanwell power supply, and how's it working out for you? Is it meeting those wide temperature ranges?
That's one of the reasons we picked it, because the temperature range on the temperature curve, like you guys mentioned before, it actually was able to operate at 70 degrees centigrade. So that was one of the pluses that we actually inclined to select the power supply.
And how long have you been using it? How long is it in the field? Which would be proof of it working well?
Well, we've been manufacturing this equipment for over almost 7 years, and
Awesome.
We haven't had any replacements or warranties claims on when we actually have those units installed on those places. That's
amazing. So awesome. Great endorsement for the product. Thanks for sharing, Gabrielle. We appreciate it, buddy. Brian, you want to add anything to the different types of cooling methods that we have here?
Yeah, I mean, just go to if application that are used, application that are going to be outdoor use, I would highly suggest to use encapsulated power supply. We have encapsulated power supply, fully encapsulated. It's fanless, dust-proof, rain-proof, that suitable for use at low temp and high temp, and high power. Now we have up to 1,000 watt. So those are for outdoor. Because for outdoor application, and for indoor, and then you have to deal with temperature inside the product, and then the ambient temperature of the power supply is have opening, and then have the fan to pull the heat air out, and as filter. Okay, if you have concern about dust, and at the filter at the opening, that's going to help you take the heat out from the system. Okay, so that's gonna, and then the power supply won't be overloaded or go into over temperature protection.
All right, that's great, Brian. Hey, so Gabrielle's using Meanwell power supplies. Anybody that's currently using a Meanwell power supply in their products, just type Meanwell in the chat and see how many of our attendees here are actually currently using Meanwell. And if you've never used Meanwell before, type no, and so we can see how many of these attendees are actually using Meanwell. Awesome.
Yeah.
That's great. All right, guys. So let's get on to the next slide here. Let's talk about AC input derating, and that is not being considered in the design here. So now some power supplies have a derating for AC input, and we shared an example here. Now, if you see in this particular example, this graph shows the percent load versus the input voltage. And you can see here that once you go at 100 volts AC input and lower, your percent load of the maximum rated load is going to drop. Now, Mike, why does this happen in some power supplies, and not all power supplies, but many power supplies?
Sure. Well, in this case, what happens is, typically power supplies are designed around 100 volt to operate at 100 volts VAC. And that seems to be the low line standard for North America. But what could potentially happen is as you get into a brownout condition in certain applications, especially in the summertime, where that grid voltage can dip below 100 volts, the input current starts to go up. And as that input current starts to go up to maintain that same power, you end up with internal temperature rises. Now, a couple things could happen. One scenario is you can end up with a temperature rise that's hot enough to actually trigger an over temperature shutdown, or what could typically happen is that power supply will just get stressed over time and operate with less reliability or less life of the product.
And Brian, when will maybe you can explain, when will we see like 100 volts AC input or less? What kind of situations can that occur?
Usually in Japan, so Japan nominal AC voltage is 100 volt. So, but there's some case where you're going to see a current going down. Meaning, the power supply will see about like 90 volt. Okay, so that I think Japan is the only country that you may see 90 volt. So, at 90 volt, I mean, like the curve you saw earlier, is typically power supply would need to be derate. So the rule of thumb, okay, in general is designed with merchant. Okay, not just the power supply, also. But also the wiring as well. So for power supply, I would suggest to derate 30%. So meaning that, for example, if you have a 100 watt power supply, use 70 watt only. Okay, and for wiring, you have your AC wiring, 18 gauge, for example, can do 8 amp, just do 5 amp. Okay, or use higher wire gauge to accommodate the voltage drop across the line when it go down to 90. So it really don't go further down, especially for application where you have long remote mount power supply and also have DC train. Okay, DC training, you go long, and then it's not good. Okay, so those are the things that need to consider when you're doing the design.
Very good. And there's also situations where here in the States we can have that occur also, right?
Right. Well, you have a brownout condition, as I mentioned before. But also, as Brian mentioned, there are different types, there may be different interconnections within the AC system. So from the time that you actually get the feed from the main power to the actual power supply inside the system, there might be some potential drops. And that's why it's not just as important to have the right cable gauge, but also to make sure that those interconnections are really tight, because that's where the voltage drops occur also.
Right, very good. So the bottom line here is, if you have that concerns of low line derating, just every data sheet, if it exists, there's going to be a graph on the data sheet. Meanwell's data sheets are probably some of the best data sheets in power supply industry. They're really clear and concise and provide all the relevant information. And if they have derating at low line or low AC input, you're going to see a graph. You just got to take a peek. It's usually on the second or third page of the data sheet, and you can make sure you're not overlooking that. Okay, guys. Well, right now I want to get to the next thing here. I want to talk about our offer. This is an amazing offer here. So 25% off, right? So we have our lowest published pricing on all Meanwell products. We're offering 25% off that price. Now, that offer is exclusive for the webinar attendees, and that offer expires on November 30th at 5 p.m. and it's while supplies last. So this offer, we have over $5 million of Meanwell power supply inventory in our warehouse right now. And we're willing to sell it at 25% off. That's $1 million discount on our $5 million worth of Meanwell inventory. And this offer applies to all of our present stock for Meanwell. And the restrictions are that it is required to ship before the end of the year. Now, I realize we have a lot of engineers on this call. I would encourage you, if you're an engineer and you don't really do any of the buying, take a screenshot of this right now and email it to your purchasing department, because this is the best Meanwell promo ever offered. And it also applies to only to new orders. If you would like to take advantage of this right now, you could call in to our telephone number here, and our sales team will assist you at 888-612-9514, or you can even type in the chat, call me, and one of our salespeople that are on the webinar will connect with you and get you taken care of. But this is an exclusive offer for you investing your time, because we appreciate that you're investing in your engineering skills and learning more about power supplies and how to better select power supplies. And we want to extend this as a special offer to everybody. Okay, next topic here. This is a really good one. So power supply that is selected and not an appropriate fit for the type of load. Now here, designers need to be aware of a power supply's type of built-in protection. So every power supply has two types of protections. It's going to be an overcurrent and overvoltage. And you need to be aware of what type of protection modes they are, because they're not all the same, and how that's going to potentially interact with your load. Now, the first type of overcurrent protection we're going to talk about first is hiccup mode. Now, we have hiccup mode and constant current limiting. Brian, let's discuss the overcurrent protection mode of hiccup mode and how that works.
Okay, so power supply is output device. It's output power, so it's usually built in with a protection mode like hiccup mode, meaning every time you overload the rating on the label, then the unit would go into hiccup, meaning that the output voltage and output current going to be hiccuping low and high, just like the pulse string. So it's keep going low and high, infinity until the overload remove. Okay, then the unit would automatically recover its output. And it's also true when you have a short circuit. Okay, when you have a short circuit, the unit also, the output would also enter the overload hiccup mode as well. And when we talk about hiccup mode, this and constant current limiting mode, the advantage and disadvantage between the two. Since I'm talking about hiccup mode, the disadvantage of using hiccup mode is your application. If you're using it for capacitive load, inductive load, hiccup mode power supply not going to do. Okay, because those capacitor or inductive motor, they pull high current when they start up, so the unit is going to go to hiccup mode, and the motor going to be like, you're going to see the motor also hiccup as well. Okay,
Brian, when should we use hiccup mode then? So when is hiccup mode a good protection mode for a power supply application?
Yeah, advantage, that is advantage of hiccup. When you use hiccup mode is when you have a power supply low output connect to multiple multiple devices. So in case if one device short circuit, okay, you want to limit the energy going to that devices, okay, to prevent hazards. And so when, for example, you have one go to MCU and then one go to control board, and if the MCU short circuit, all the current going to go there. And with the hiccup mode, meaning the energy are limited. Okay, so it won't create all the hazards that may burn the wirings to limit the damage, basically. So that is one of the advantages of using hiccup mode.
So let's talk about constant current limiting. So the other overcurrent protection is going to be constant current limiting. And maybe we could elaborate on when that is the appropriate overload protection mode for an application.
Yeah, constant current limiting, meaning unlike the hiccup mode, it's going to output a constant current when you overload it. However, the voltage is going to drop a little bit to maintain so that it's not the power are not over, so it won't fail. And the advantage of using the constant current limiting is, like I said earlier, for capacitive load or inductive load. So because those, when you start up, it pull high current and the power supply have to give it juice. So keep giving it power current so that it can start up first. And after that, it go down to steady, then it's going to be fine. Okay. And so that is the advantage of using the constant current limiting feature.
So, hey, Brian, Ken makes a good comment here in the chat. And he commented and observed that in external adapters, most external adapters are hiccup mode. And it's really not offering of other type of overload protection mode on adapters. There's a reason for that. So what would that reason be, Brian? Because those adapters are intended for certain type of applications. Maybe you can elaborate a little bit on that. Yeah,
I mean, adapter usually they are designed with hiccup mode. The main reason is for number one, application. Not many applications they use adapter for motor or charging capacitor. Really. Right. Number two is, like I said earlier, you want to limit the energy or power when it's there's a short circuit inside the equipment or the equipment is being powered, because those are external use. Home use, it's better to limit the energy than not power up the device. That is the two main reasons.
Very good.
Actually, and just a comment on that, there are, when you connect adapters to portable devices that have batteries that are charging, there's usually a battery circuit that is monitoring how much current the battery needs to get. So the adapter won't see that. It would be completely protected from seeing let's say, a dead battery on there. There'd be something to actually limit the amount of current going there.
Hey guys, everybody, if you're getting value out of this webinar so far, just type a TRC in the chat. I want to see if you guys are getting some value out of this content. Make sure that this is something that you guys are finding useful and valuable. All right, cool. Very good. Okay, so let's get on to the next part of this here. Over voltage protection, right? Mm-hmm. So here, let's talk a little bit about over voltage protection. Brian, how does over voltage protection get triggered in a power supply?
So just like overcurrent protection, most of the power supply, when it designed, it comes with the over voltage protection. Two main things is one is, in case there's a defective component inside the power supply, is the output voltage may rise above what is supposed to be regulated, and it may cause damage to the end device. So with the over voltage protection, it's going to clamp. So for example, a 24-volt supply, it's may clamp to 30 volts, basically to limit the damage. Okay, and that is the purpose of having the over voltage protection design or integrate into the power supply. However, for when we were talking about motor application, so those applications need to pay attention is may generate back EMF, okay, or what we call induced voltage. Those voltage may induce back to the power supply output, or the current may go back. That may trigger the over voltage protection of the power supply. Okay, so in that case, we usually suggest to add the blocking diode, okay, between the power supply output and the motor, or at a battery bank, a capacitor bank, so that it can absorb the induced voltage. Okay, so those are the suggestions. Also, if you want to go more deep into it, is using a snubber network, okay, in parallel with the motor. So it's basically providing a path for the current to flow instead of going back to the power supply.
Brian makes a good point here. We've actually had a couple of applications where the power supply was operating a motor that was operating a big load. And when you stop the motor, let's say by just cutting off the power on the motor, what ended up happening was that motor would put that energy back onto the power supply. And sometimes you get an oscillation. And when you get an oscillation, you might actually get the voltage going negative for a short period of time. And that could also trigger, not just trigger the overvoltage protection, but also damage the output capacitor of the power supply. So in that case, we actually encourage also, like Brian said, either a snubber network or a freewheel diode to keep that voltage from going past 0.3 volts with the Schottky, which is typically what would happen, to keep that voltage steady to go below 0.3 volts.
You know, you can see it's pretty complex selecting a power supply. And, you know, we like to pride ourselves in eliminating those complexities and simplifying the process. Brian, maybe you could just share a little bit how important it is for manufacturers to work with a distributor that is an expert in this area so that they can help them select that right power supply and qualify it. Because a lot of engineers are, you know, you do-it-yourself type of people. They like to do their research and come in with the product. And then when we bring that lead opportunity comes into us and we start the qualification and we really make sure we're qualifying. We do some rapid fire questions to really make sure we understand what their real needs are. You could just talk a little bit briefly about the importance of working with somebody that knows the product, especially a brand like Meanwell, where you have thousands of models to choose from, and it's impossible for somebody to be familiar with it if you're not working with them every day.
Yeah, so I mean, I think we went to 1, 2, 3, 4, and really toward the end is like the first question to ask: what are you using it for? Like, I mean, that's usually when I work with the TRC application engineering. So the first question to ask: what are you using it for? I'm usually customer come with like, you know, I need 24 volt minimum 300 watt, and then it's gonna be difficult. I mean, then the first point is basically, yeah, what are you using it for? Outdoor, indoor application. Then we can narrow down. Should we go with adapter, enclosed power supply, open frame? And then after that, we can go deep into the temperature rating of the power supply. And you know, and if we go into temperature issue, and we can help customer to do thermal test, you know, thermal test to ensure that the derating is good enough. Okay, even low voltage test we can do, and I believe TRC does this all the time. You know, help customer do all the testing. Okay, when it needed, and then to make sure that it doesn't have issue when you go into the field, because those may cost you like 10,000, 5,000, 10,000, 20,000 to fix it in the future. You don't want that. So design build in the power supply is a complex. It's not simple. So talk to us, talk to TRC, okay, and then I will help, you know, select a good power supply for the right application.
Yeah, and the other thing is, you guys are always, Meanwell is always releasing new products. You know, it's just, you're known for always expanding the product offering. And not only are you need to pick a technically correct power supply, but also you need to pick the newest, because the newest is always going to have is going to be at a better price point, and it's going to have a longer lifespan. It's not something that's going to go end of life, and you're going to just a better selection. So not only do you want to pick the right power supply, meet your specs, but you want to be getting the newest and greatest.
Yeah, actually, and that's when anyone calls TRC for a power supply selection, we'll go through a set of questions, and those questions are going to be consistent regardless of who you call, any of our power specialists.
Right.
And when we start asking those questions, it's amazing how many times we get, hey, you know, that's a good question. I didn't even think about that.
Right.
And we're asking that question early in their design. That's when we really can make the biggest impact on their overall project.
Very good. So, hey, Brian, let's just finish off that over voltage protection, and let's talk a little bit about back EMF from an inductive motor causing an over voltage protection shutdown. You just want to just go through that real quick here.
Yeah. So because, you know, inductor or motor application, they usually, you know, when it start up, it had it pull current, and then it induced the voltage back to the power supply, and that may cause the power supply to go to over voltage protection. So like I think Mike earlier said, you know, you use a freewheel or a blocking diode going to help you to prevent the power supply to go to over voltage protection mode. Or another way is to, if you could, do soft start then soft start may reduce the current, increase the current slowly, and so that it doesn't induce that much voltage going back to the power supply.
Hey, we got a couple cool comments here. I want to get, is it Achilles unmuted? I want to share about the case which they switched to a newer power supply, save 30% on the part cost. I'd love to hear about that.
Hey, Stephen, how you doing?
Hey, I'm great. How are you today?
Doing great, doing great. Nice to be in the seminar. Nice to see everyone involved.
Yeah, thanks for participating. I'd love to hear about it. So what were you using? What'd you move to? Who you share a little bit about it? We'd love to hear it.
No, so we just went up to the newer Meanwell power supply. We were using the SP750. And we went, once that one went obsolete back in 2019.
Yep.
The newer one was cheaper, which is very, very impressive. And also our other power supply was the PPS 24. We're gearing up to move to the newer one, which is the EPP 24, and that one is also almost 50% cheaper, which we were very, very surprised. For better specs,
Right.
and better performance, we were getting significant cost savings.
How'd you learn about the new models?
Oh, actually, I think it was TRC that brought them up in our case. Just because they were obsolete, we got letters from Meanwell notifying the obsolete timeline, and then we contacted you guys, and I think you suggested the EPP 24, if I'm not mistaken.
That's great. So it's working out for you, right?
Yeah.
Hey, excited you joined today. Good to hear from you.
Thank you.
And we have one more I want to, let me see here in the chat. Let's see, I want to hear from Jerry Bridges. Jerry Bridges is talking about only one other company comes close to Meanwell in quality, Inventronics. However, he's having a lot of trouble ordering them. He said 6 months, terrible. I'd love to hear about this. I'd love to learn more because maybe we could solve some of your problems, Jerry. You ask,
Yeah.
Hey, Jerry, how are you doing today, buddy?
Hey, I'm doing all right.
All right.
I've been on the hunt. I've been very concerned about how tariffs affect the cost of doing business right now.
Yep.
And so as a result, it's kind of forced me to look at Inventronics. And I have a relationship with the CEO. We both went to Virginia Tech. You would think I would be able to get some special consideration, but they
He's
just
not giving you a
cannot
special
provide.
deal, you mean? He's not giving you any special deals?
Not a chance.
I think you maybe got a better deal today than the guy you went to college with.
Yeah, I saw that. I sent that to my partners just a few minutes ago while we were on the call. I really appreciate you guys offering that. You know, we have a lot of projects working in the States, in Florida and Georgia, and I want to be able to provide the best quality product to the customer. So this isn't just a cost thing.
Yes.
It is almost impossible to find a driver that competes with the Meanwell HLG series. And in testing, it proves that it's a quality product. When you're getting a power factor rating of, 0.995 or better, and you have a harmonic distortion that's less than 4.0, that's just unheard of with other products. So managing the power is very important.
That's great, Jerry. Yeah, so if, Meanwell is a real leader in the LED driver market. Meanwell does have some of their drivers that they're manufacturing in Taiwan. They did move because Meanwell has a few, and Philippines, they do have multiple factories. So, if tariffs are concerned, I'm not sure if you've investigated that. Maybe you could connect with one of our people here and we can see what you're actually looking to use. And we could see, because we have a whole line that's manufactured, the next gen HLG series. There's a lot of that product being manufactured in the Philippines right now, which avoids the tariffs. But the nature of that business, as you probably observed, a lot of LED driver manufacturers are manufacturing in China because it's so price competitive. And even with tariffs, it can still be less expensive buying a China-made product than other countries. All right, very good, guys. Hey, I love hearing from everybody here. Let's see what we got in the chat here. Or uses HLG series, but meanwhile, I have a hard time with getting these. Hey, let's unmute Rachel Bauman. She's having some trouble. Maybe we can help her out a little bit. You getting your ass to unmute, Rachel? She accepting the unmute? No. Okay, that's okay. We can move on if she's not available. That's okay. And I see Chris at Holiday Lighting would like to see, be nice if LRS series was made in a tariff-free country. Hey, Brian, so we manufacture the LRS series. I think that's in Guangzhou in China. And maybe you could just share why we manufacture that particular product in China as opposed to another country.
Yeah, I mean, LRS series is one of the first Meanwell product series that do automatic manufacturing. So there are no manual insert, no, everything is online. So basically we just put the component in and it's automatic from beginning to the end. And only people to do it to put the power supply in the box. That's the manual. So that is one of the reason it started in Guangzhou. So a lot of things need to consider if you're going to move to Philippines, because the whole automatic line may need to move. It's not a small investment for us. But as it is right now, the cost is very good for LRS. Okay, even it making China.
Right. So Brian, so as I understood it, because I've worked a lot with Meanwell, I'm really close with Meanwell. I'm actually on their advisory committee for North America, so I get a lot of information. I visited that factory when it first opened up, and that was pre-tariffs. So the reason that product is so competitive is because of what Brian just explained, the automation, and that automation was set up in a factory in China. And for Meanwell to like pick that up and move that into another country would be really cost prohibitive, and we would lose all the competitiveness of that product. And even so, with the tariffs, it's still a competitive product. Unfortunately, these tariffs are pretty persistent or here for a while. Would you agree with that, Brian? Yes, correct. I mean. It's not like nothing is not doable. I mean, it had to be, a lot of things need to consider if you're going to move the whole line to Philippines. It's got to make economic sense, right, in order to provide true value to the customers. Correct. Yeah. All right, let's get on to the fifth problem here that we had today. Now, here we're going to talk about when a designer doesn't account for high AC inrush current from power supplies. Now, this can occur when we're connecting multiple power supplies on one AC circuit branch. Brian, what happens when we connect too many power supplies to one AC circuit branch? Yeah, I mean, it possibly would trip the circuit breaker, okay, the front end circuit breaker, because each power supply would have its own inrush current, because it's required to charge up the bulk capacitor when you first turn on. It's only happened when you first turn on the power supply, the first time you do it. Okay, and the inrush current would last about 2 to 3 milliseconds. Okay, and it's also proportional to the AC voltage that you are putting in. So, for example, in North America, you put in 208 or you input in 277, the inrush current go higher. So higher is 277, and then it's going to go 208. Okay, so typically it's about 60 amp for one power supply. And if you do 120 only, so 120 is going to drop by half. That's the rule of thumb. Okay, it's going to be 25 amp. And now if you have multiple power supply in one application, then when you first turn on the AC power, it may trigger, may trip the breaker. So I usually suggest you use tap D, okay, because tap D breaker is basically has the lowest tripping curve for all the breaker. And so Brian, can you reiterate that again? What's the recommended breaker to use? It's called tap D. So circuit breaker, they have many different tap B, tap C, and tap D. So each of those meaning is have a different tripping time. So the duration, how long is it trip? The breaker, basically how long it's going to turn it off itself. So the D tap is has a longer tripping time. So it's better to use D tap when you have multiple power supply in one system. Okay, and or we have the inrush current suppressor. Okay, it's called ICL.
those are particularly designed for multiple power supply using in one application that you can consider. It helps you to suppress the inrush current. And so you don't have to worry about a breaker, okay, or changing the breaker at all.
Yeah, and actually, so what Brian mentioned, in case you have multiple power supplies, the other option would be that our customers are using these AC relays. And what these do is they'll time the turn on sequence of the multiple power supplies. So even though you do have an inrush current, you have less inrush current, you just have multiples of them, and that rides through the turn on of the system without tripping the breaker as well.
Very good. Hey, I saw that we had a question here. Somebody just didn't have a mic. TRC team, Melissa. So Rachel Bauman didn't have a mic, but she's having, they're having trouble finding some drivers, having a hard time getting these. Somebody private message Rachel, and let's get her problem solved. All right, Rachel, we're going to do everything we can to get you the drivers we need. One of my team members will message you privately, and we'll get connected with you, and we'll get you taken care of. It's our job. Already done. See, we're already working on it. There we go. That's how we operate here at TRC. All right. Look, our bottom line is our mission is to help you guys succeed, and we're going to do whatever we can to help you guys. All right. So I want to just summarize this offer here one more time, guys, because this is an awesome offer, and I give you another chance. And just if anyone has any questions about the offer, you can put them in the chat, and Melissa Sherman can answer them. But again, our offer is 25% off. Our lowest published pricing on every Meanwhile product we have in stock. If you call in, you mention the promo code Meanwhile25, and we'll know why you're calling. You call in at 888-612-9514. We've got $5 million worth of Meanwhile inventory. We're going to discount it $1 million. And so it's subject to sale. So this is only while supplies last. And we're only running this for 2 weeks. So screenshot this, send this to your purchasing team, and we're going to get them taken care of. So this has really been great, guys. Hey, Brian, I love it. Mike, great job. Do we have any questions in the chat? Hey, Melissa, do we have any questions in the chat or that we can answer for anybody before because we got another 8 minutes or so. I want to make sure everybody there's anything either technical or non-technical, anything I can help anybody with. All right, good. Chris is already emailing Joelle. Nice. So she's already knows, she's connected with Joelle about questions. Great. Go ahead, Melissa.
Yeah, Stephen, I actually have a question. So where do you recommend an engineer to start when they're actually selecting that power supply?
Right, that's great, Melissa. So, Brian talked a little bit about this before. We have a system here in the organization, and we have everybody follow like a script here in terms of finding, identifying what an engineer needs. So the first thing an engineer needs to understand, or a system designer, is they have to understand their power conversion. So what's my input voltage range going to be? What do I need for an output voltage? How many output voltages do I need? What is my maximum power? And additionally, do I need any features and functions? Do I need some remote sensing, remote on off? Am I going to need any type of features and functions? Also, they're going to have to understand what my environmental conditions are, because if I don't understand my environmental conditions, which we talked about earlier, I'm not going to be able to pick the proper power supply. What kind of cooling will work in the type of environment I'm in? What is my operating temperature range going to be? What's the lowest? We had somebody share that they're operating in Canada and Dubai. So they've got a real wide variety of operating conditions. So we've got to understand the environmental specifications. And also, well, what are my mechanical requirements? Some systems, you've got a lot of flexibility, but some systems you've got size constraints. In addition to that, in terms of mechanical, what type of form factor? Am I looking for a power supply to be embedded? Do I want it to be open frame? Do I need it in a chassis and cover? Can I get it outside, external from the system? I want an external power supply, such as a desktop adapter. And then additionally, the fourth is you've got to understand your safety and compliance requirements. Depending on your application, you're going to have safety regulation requirements. and also other compliance issues that you're going to make sure the power supply complies to. And this is where we help our clients out. So we'll make sure when a client comes into TRC Electronics with a power supply requirement, we're checking every one of those boxes so that you don't find out 3 months later that, oops, I forgot about this, and now I'm in trouble, and I just lost 3 months, and now we have disruptions in the supply chain. Well, actually now it's costing me 6 months, and now the product's going to cost me 10% more because we have all these inflationary pressures. And so once you get all that data, an engineer or system designer can do one of two things. They could go shop on a lot of websites and spend many hours going through products they're not familiar with and trying to find the right product and not knowing if that's the newest and greatest. Or they could call TRC Electronics, take 5 minutes on the call, and we'll get you on the perfect power supply the first time.
All right, thank you, Stephen. We actually do have some questions in the chat as well. We've got Clint.
All right, let's unmute Clint now.
Hello.
Hey, Clint, how you doing today?
I'm good. How are you?
Awesome. What can we do for you today? What's your question?
Basically, we manufacture LED mirrors and we use the LPV series quite a bit for that. Some of the commercial applications, they have the 277 volt. We have to step that down, to the low voltage 12 volt. Usually we let the electricians handle that part of it. But I was wondering if, Meanwell makes a driver that would accomplish both, where we wouldn't have to go through that process.
Right, so you're using the LPV series. So Brian, I'll let you answer that because we all could jump in here. The LPV series is probably one of the best seller LED drivers, and it's really cost competitive and has like an 85 to 264 volt AC range, and that helps make it competitive. But Brian, you want to chime in here?
Yeah, as I know, mirror application, the form factor is very important. So we do have a series called LPF or NPF. Those can take 277. Okay, the form factor is very close to the LPV. Or we have the XLG, the new generation LED driver we have. XLG, those also take 277. Those are the two that I would suggest you to look into. Though, yeah, and then the rest of them, I think the form factor may be too large to integrate into the mirror. And SLD is also another small form factor that you can use, SLD 50 and 80. So those three product series you can look into.
Yeah, the trade-off is going to be when you move from the LPV to these other series. Well, they're going to have a wider wider input voltage range, and you're going to pay a little bit of a premium for that. So it's going to require a little bit more investment. So Clint, you might want to consider whether you, I don't know if that's in every application, I forget what you said, or just some, but you want to explore that. Clint, one of my salespeople can message you right now, and then we can just get your number, and they'll get on the phone with you and walk you through your options so that you have peace of mind of what the options are and give you all the information you need so you can make a decision.
Okay, thank you.
Very good, I appreciate it. And Melissa, we have any other questions? I mean, we're like, we got 2 minutes left here, but we got time for one more if we do.
Yeah, Gabriel has another question about online selector tools.
Okay, specifically, is it just simply online selector tools?
Yes, are there any power supply selector tools that they can use available, or should they contact somebody for help?
Right, okay, I can answer that question. So on trcelectronics.com, when you go to the particular product category, we have product filters in the left column. And once you select those product filters, it will narrow down the selections. But if I'm you, I'm calling in and taking 5 minutes and just eliminating all the trouble. Look, most distributors are making a website so that they don't have to talk to customers. We want to talk to you and help you and understand everything that you need, because you may even have requirements you're not even aware of, and we can help you walk through that. So you've got the product filters on our website that you can narrow down to selection, but we have our 188 number on our website. I would just give the office a call, and we're going to save you a lot of time. All right, guys, looks like we're out of time here. You know, this was a great 1 hour. Really appreciate everybody joining us today. We loved having you and that you invested the time today. TRC Electronics and Meanwell together have been partnered for over 20 years. We have an amazing partnership and we're supplying a lot of businesses in the electronics industry the power to succeed. Thank you, everybody, for joining us. We hope you have a super successful rest of the day.